Good night, everyone. So we are from Group 4, where we're going to present our final presentations for Environmental Research Online Workshop by Ming-Chi University of Technology and Universitas Andalas. But before I start the presentation by Group 4, I would like to say a huge thank you for all the professors brought from MCUT and Universitas Andalas for the precious opportunity given to us. Next. So I would like to introduce my team members, starting with me, Finda Fahira, Ashifa Adetya, Andini Fientri, Choirunisa Justika Asih, Hafiz Syahputra, and Muzakkii Faaiz. Next. So for today's presentations, we are divided into two main topics. The first topic will be Chromatite Ca CaCrO4 in soil polluted with electroplating effluents, and the second topic will be lead pollutions of sodium soils. The first topic will be presented by my fellow friends, Andini Fientri. For Andini, time is yours.
Thank you, Finda. So I will explain about chromatite in soil polluted with electroplating effluents. Next. So this is the journal reference we use to arrange the material. Next. And for introduction, one of the waste of the electroplating industry is chromium. The form of chromium in natural environment is usually chromium-3 or chromium-6. Source of chromium can found in volcanic gas, weathered rock, utilization of chromium compounds. Next. So for chromium-3 and chromium-6, effect on organism is Cr ion keep it 6 valence in contaminated soil because of a high redox potential caused by the presence of oxidizers such as oxygen. Chromium-3 is essential micronutrient for development of human and animal, and chromium-6 can be toxic to the environment and organism, like disrupt DNA synthesis, cause mutageneous mutation that lead to cancer cells, cause teratogenic process to be activated. Next. And for the characteristic of chromatite is, as you can see in the slide, chromatite have a tetragonal crystal system. Lemon yellow precipitates are coated in soil covered and format in soil contaminated with chromium-6 which react with mineral substance. And conversion from chromium-6 in chromatite to chromium-3 using organic carbon as reducer will increase chromatite solubility. It's from modeling of the reduction process applying the PHREEQC programs. And for the next slide, will explain by my friend Faiz.
Okay, thank you. For the next slide, I will talk about environmental pollution in Zabirzo, which caused by electroplating effluent. Electroplating effluent having pH 6.2 to 7.8 and contain up to 1000 ppm of chromium-6 were directly discharged into the soil. In 1978 to 1989, there was an active line carrying out chromium, copper, and nickel electroplating as well as degrazing. In 1994 to 1996, concentration of chromium-6 reached 0.39 ppm. The high concentration of chromium-6 were due to leaching of chromium compounds by rainwater from polluted soil. And precipitates of the chromium-6 compound in the form of chromatite were found in Zabirzo. The total concentration of chromium in soil reached 6,100 milligram per kilogram, including chromium-6 up to 570 ppm. Next slide. In this slide is about method. Mineralogical investigation of the precipitates were carried out using X-ray analysis or XRD, infrared spectroscopy, IR, scanning electron microscopy, SEM, with energy dispersive X-ray spectroscopy, ADS, for chemical analysis. Next slide. And here, as we can see, the picture, the SEM observation indicate the precipitate are composed mainly of grain 5 to 30 micrometer large. In the form of strongly shortened, the tetragonal bipyramid with tabular habits. And in the below section, we can see the prismatic grains reach a length of 20 to 100 micrometer. Their shape are most often xenomorphic and idiomorphic. Grains occur sporadically. The surface of the grain is fractured and rough. The salt elements found include calcium and chromium. And we can see on the right the result of the analysis by EDS. It indicates element calcium and chromium composition of precipitates, and gold is from sample coating. Okay, for the next slide will be continued by Hafiz. To Hafiz, time is yours.
Thanks to Faiz. Analysis by XRD in graphic 3 explained XRD indicates the main minerals in soil which the yellow precipitates or occur include quartz and calcite and accompanied by class of the elite group. And graphic 4 and the main crystalline component of the precipitates is chromatic and initially identified in the X-ray patterns from presence of the 3.62, 2.68, and 1.85 atmosphere reflection, and analyzed by infrared. In infrared analysis saw me the presence of a single characteristic and sharp band at 179 centimeter and assigned to the volume asymmetric stretching vibration of the chromat group. Next. So in the precipitates chromatite and about graphic 3, the main crystalline component, and the in detail X-ray analysis by comparison with 34 diagnostic reflection by synthetic chromatic and the unicellular cell parameter of synthetic chromatite have a value A and B and determinate for chromatite. So this indicates the chromatite doesn't contain a mixture that can be determined from other elements and doesn't affect other elements. This is about the chromatite and return to Unifinda.
Okay, thank you, Hafiz. So we will continue to the second topic of our presentation today. So the second topic will be about the pollutions of sodium salts. Next. So basically, our presentation today is based on a research article under the title "Lead Pollutions of Sodium Salts," where a total of 8 milliliter sodium grains were used for the study, and the cell samples were also collected at each of the 8 sodium range at the burn, target line, 50 and 100 meters from burns. Next. So as you can see on the slide, this is the map of Botswana where its soil is used for the research samples. Next. So the brief introductions of today's topic is there's an elevated amount of lead or PB found in civilian cells that is emanating from salts and bullets that use in military activities in the shooting range. It is also found that in several countries, there are PB polluted soils in USA, Netherlands, Denmark, Sweden, Finland, and England. In the soil, PB bullets can undergo a variety of reactions such as oxidation, carbonation, and hydration, which is convert them into soluble compounds. Next. So these are the harmful health effects of PB that can found in the children's bodies and also in adults. So low level of PB in children's bodies could cause several damage to the body, such as damage to brain, nervous system, behavior and learning problems, so on and so forth. And also the exposure to PB in adults can cause reproductive problems, decreased fertility, high blood pressures, digestive problems, so on and so forth. Next. So have you ever wondered why there is an elevated amount of lead or PB found in soothing rain soils emanating from salts and bullets? So basically, PB is a preferred material for emanations manufacture because it has several characteristics that fit best to become the materials of emanations, such as low melting point, high density, high resistance to corrosion, and also high malleability. It also has been found that the large quantities of PB found in the soil at the soothing range have direct relationship with the ease through which the PB bullet can be transformed into species that can easily dissolve and diffuse into the environment. Next. So about distributions of total PB contaminations will be explained by my fellow friend Sifa. For Sifa, time is yours.
So thank you, Finda. So the next point of this presentation is distribution of total PB contamination in shooting rain soils. All the shooting rains studied were contaminated by PB, and the highest total PB concentration were found in the berm soils. As you can see from the graph at the slide, there is four graph, and the graph A is for the berm soil, the graph B is for the target line soils, and C is 50 meter from target line soils, and the graph D is for 100 meter from target line soils. As I said before, that highest total PB concentration were found in the berm soils, and the second highest was the target line soils, total PB concentration. But the total PB concentration at the 100-meter setting line were higher compared to the 50-meter setting line for the monsoon range. And next is the mobility of PB and soil simulated by SPLP. And there is a possibility of PB to contaminate the underground water under favorable environmental condition. And the method that we use in this research is SPLP, or the synthetic precipitation leaching procedure. This procedure designed to determine the mobility of both organic and inorganic analytics present in liquid soils and waste. And this SPLP method is designed to evaluate the impact of contaminated soils on groundwater. SPLP has been widely used in areas with highly polluted with PB to assess the possibility of underground water contamination. And next, as you can see, there's two graphs on the slide. And for the first graph, from this research, in all of the in all of the 8 shooting range, the background total PB concentration were less than 10 milligrams per kilograms in all of the shooting range studied. This implies that PB mobility may be restricted within the shooting range and their intermediate surrounding. And the mobility of PB in the soil due to rain acid was simulated using the SPLP procedure. As you can see from the second graph at the right side, the SPLP PB concentration was highest in the berm soil of the SH range. And in all of the 8 shooting range, studied SPLP PB concentration exceed the USEPA in 0.015 milligrams per kilograms critical level of hazardous water. So this indicate that some of the PB may have leached out from the shooting range soils and giving rise to possibility of surface and groundwater contamination. So for the next point is mineralogical and chemical transformation of whether PB and shooting range soils will explained by Choirunisa. So Choirunisa, time is yours.
Okay, thank you. Now I will talk about mineralogical and chemical transformation of weather-bleed in shooting range soils. The chemical transformation of the weather-bleed bullet was determined by X-ray diffraction. The phases in pulverized berm soils was analyzed by X-ray diffraction using copper K alpha radiation at 30 mA and 45 kV. The weathering products of lead bullets and shots at all the 8 shooting range were predominantly carbonate, specifically cerussite and hydrocerussite. The soil pH plays an important role in the corrosion of lead shots and bullets and formation of weathering products. At MOG shooting range, hydrocerussite was the only dominant lead carbonate weathering product with no trace of other lead carbonates. This could be due to the favorable high pH, which is slightly above narrow into the alkaline region. The other 7 shooting range had a mixture of both cerussite and hydrocerussite. Next. As you can see on the slide, this is X-ray diffraction patterns. X-ray diffraction analysis patterns indicating the weathering products of lead bullets in the H shooting range soils found in southern and central Botswana. Q shows quartz, C shows cerussite, and H shows hydrocerussite. Next. The conclusion of this material about lead pollution of shooting range soils is the total lead concentration in the berm soils in the 7 of the 8 shooting range exceeded the U.S. Environmental Protection Agency critical value of 400 mg per kilogram. The PAJ R2 shooting range showed total lead concentration of less than 400 mg per kilogram due to the fact that it is a pistol shooting range. Pistol ammunition contains less amount of lead slug of about 52% as compared to assault rifles with over 80% lead slug content. The SPLP lead concentration in all of the 8 shooting range exceeded the U.S. Environmental Protection Agency 0.015 mg per kilogram critical level. I think that's all from me. I will return to moderator.
Okay, thank you, Lisa. So that concludes our presentation today. On behalf of Group 4, I would like to say thank you for your attention and have a nice days ahead. Thank you.